Hello everyone, thank you for joining us for today's webinar, Studio 5D Planner Auto Layout Tools. To introduce you to our presenter today, we have Lee Poulin, who has been a mining consultant with us for almost 3 years. Lee is a mining engineer with extensive open-cut coal mining experience. With CAE Mining, Lee consults and provides training and support for open pit and underground mine optimization, design and scheduling. Thanks very much, Lee.
Thanks, Eloise. All right, today's session is on Studio 5D Planner, the auto layout tools, and just some background on it. The auto layout tools are available to all Studio 5D Planner users who have the underground licenses. So yeah, there's no special licenses to get that going. And the purpose of the auto layout tools is to make it easier to do repetitive design tasks. That's anything that kind of has a pattern, something that repeats. I'd say from my previous experience, when doing open pit designs for blasting, you'd just copy a grid. You'd have a grid of points, you'd lay it out, rotate it, fit it. But it was very, very simple work, not creating each hole individually. So the demo that we'll have today is looking at the undercut or the development for a block caving operation. But this could also be applied to room and pillar or longwall development headings would also be well. So, but any of these designs that we have to do, it needs to be pattern based, and we need to be able to build it up sequentially. So to prepare to run auto layout tools, we need to be aware the auto layout tools only work on the FXS design types. The first step is that we need to set up our design definitions and our cross sections for everything that we will be creating for. If you weren't using auto layout tools, you might keep the design items to a minimum. But because we're doing things in an algorithmic manner or sequential, you might need to set up things differently. You can see here that I've got things set up for whether something is on the left or right, a first or even or odd number design types, and that's just the objects will be the same whether they're even or odd. The left or right probably should be the same, but because I'm doing this automatically or using the auto layout tools, I have to be specific about creating a design definition for each different type of object I'm going to use. We can also set up the cross sections, which those who are familiar with 5D Planner will be familiar with. And so once we have those steps ready, we've set up our cross sections and design definitions. The second step is to set up our initial design strings. So this will be the first strings drawn into your FXS file on which the rest of the auto layout tools will use. We're also able to set up control strings or surfaces which can be which the auto layout tools can interact with, but are outside the FXS design. So once we've got those two things ready, we can start creating our auto layout activities. So some things to remember about this. The activities happen sequentially. So if you have an activity that requires a certain design type, if that design type hasn't been created yet, that activity will not find anything to work on. So with that in mind, we need to make sure that each activity feeds the next activity the information that it needs. So an activity has an input and an output. Here in the image we see the base the base FXS type. So that's what it will use the rules on to create a new type. We have a couple different types of operations that we are allowed to do. It's just those ones, though if there's other changes or things that people would request, that we will definitely consider that. And depending on the type of operation or activity you choose, you're able to set up different rules. So I've grouped the activities into kind of 3 different sets. Here, first we have the creation activities, which create a new string based on the existing strings. So the first one is to generate a design string. So it will find the base string, it will move some distance, or it will create a line in relation to that design string. And you'll be able to look a bit more at the settings for that when we're in the demo. There's also the option to join between 2 strings, and this is similar to your dependencies where you're searching for the endpoint or the beginning point of a string. You're able to specify search distances, search radiuses, and then it will, once it finds 2 strings that match the rules, it can create a string in between there, just as your auto dependencies would. But this is a design string. The other option is to translate strings. So whether you've already generated a design string or you've manually created a design string, the translate strings can either move an existing string or create a new version of that string and maybe give it a different design type. Then we have modification activities. So this is for strings that are already existing, that previous steps have put into the FXS file. We're able to break at intersections, so if you've got 2 sets of lines overlaying each other, one set of lines can break the other set of lines. We can also break at intervals, so you're able to specify a distance. We're able to extend strings. This allows you to pick an azimuth or a direction and a distance. We can reverse certain strings' directions. We are able to use filters to do this. And we can also trim string ends. So trim string ends is the opposite of extend strings, where you're able to, if a string has been clipped by something, you are able to pull it back a certain distance. The next I've listed as external activities. So they make design changes from external objects. So we can create slices through a wireframe. This is similar to doing plane slices. We can also create wireframe slices along a string. We can project strings to a wireframe. This would be useful if you've created a design that's very flat, but the design will actually be following the surface of some scene. You can drape the design once you've made it what you want. You can drape it onto a surface. We're also able to trim strings to a perimeter or trim strings to a wireframe. And there's one more activity. I've called it the interactive activity. So in our process, we can enter the activity Open Design in Design Window. So at this point, it will have completed the previous steps. It will open up the design in the design window. You will be able to make some edits. It's also useful for debugging. You can see what's happened so far. And then once you're happy with those changes, you can hit continue, and it will continue going through the auto layout process, taking into account whatever changes you might have made. So running auto layout, here on the screen you can see some of the design or the activities that we've set up that I'll be showing you today. These are rule sets. You can try different versions of them, modify them, copy them, and certain rules can be toggled on or off. If you only want to run the first 4 rules, you can turn off the rest. And once we've run auto layout, you're able to either accept the results or you can start again. So it does mean that the original file, or the original FXS file, up to the very end you have the option to revert back to it. Though once you've accepted the results, the original FXS file is overwritten. Alright. So next we're moving on to the demo. So here, I can start off with something fairly simple. I can check. Alright, there's a completed design. You can say I'm going to get rid of that. Sweet. Alright, so now all I have in my design is this gray string at the bottom. It's a base string. I believe it is called, in the design definitions, it is called an init string, or an initialization string. So I can come here, check my design definitions. Sorry, I've got my initial string. And you might see here, normally in 5D Planner you probably won't be excluding strings, but because here we're using some strings as construction strings or design strings, they are strings that will not actually be used in the FXS for scheduling, but we have them there so that we can use them for the auto layout process. And so I have a bunch of these. I've got my cross sections for my left and right undercutting above the draw point. There's the trough. And some simple 5x5 and 4x4 cross sections. So I'm good with that. I can make sure that this is connected to, I'm making sure that this is connected to my initial string. So this initial string is all I need set up with the current rules that I have to run auto layout. Okay, that's complete. So now I will come to my automatic auto layout tools. Okay. So in this series I have I've set up, generally I'm using a lot of I'm designing strings, translating strings, extending a few strings. I'm not using too much of the interactive or the commands that use external data, other than I am trimming to a perimeter at the end. So here, I'll just show you an example of the rules for translating strings. So the first operation that we're doing is we're taking that initial string and we're projecting it up to the undercut level. So it becomes the undercut initial string. And my rules are just specifying that my translation dip is 90. It will translate 20 meters vertically. And it's going to only create one string and it will not delete the parent string. So that's good. And then with the generate design strings, I'll open up this so you can see what that looks like. So here we're able to tell, first of all, what kind of string it's creating. So it's going from the initial string, and it's creating the the even-numbered extended strings. We are creating a line. The other option is arc. So if we were creating an arc, we could specify our radius and rotation angle. But here we're creating a line 400 meters long, and we're putting it 270 degrees azimuth from north. But in this case, we're telling it to use the parent string azimuth as north for rotation. So that means at 270, as you go along the string, it will project perpendicular to the left. It will start creating these strings from the start point, and it will create the first one at 30 meters from the start point, and it will continue doing this multiple times up to 6,000 meters every 60 meters. So that's what I have set up, no dip. So that's for the even-numbered. The odd-numbered, if I check those, instead of starting at an offset of 30, they start at 0, and they still go every 60 meters, and they're still going perpendicular to the left. Alright, what? Just with these other, so that's my first set. Then it will open up in the window, and we'll be able to see the copy of the initial string project out on the undercut layer, and we'll also see our even and odd extended strings. The next step is to create the draw points left and right off of both of those, the EXT even and odd strings. And then we'll be able to see the output of that. Then we're able to create the trough string between the draw points and extend, and then we'll move that so that the trough is actually above the draw points based on where we put the center line in the trough FXS, or sorry, the trough cross section. And then we will extend the draw points to connect in the middle and generate the undercut tunnels from which they will shoot or blast the whole undercuts. Right. So that's an explanation of what we're going to see here. So I'm going to apply those rules, and we'll be able to see it happen dynamically on the screen. Okay. So here I've got my left and right. Hopefully you can see the difference between the left and right is that they're both the same color, but they have different points. I'm able to look at this. Everything looks okay. There might be some diversion here. I'm not too worried about it at this point, but I could come and I could delete these strings. I'm fine with leaving them for now so we can see what happens. So I'll hit continue. So I can check if I've set my rules up properly. But here we have created our draw points. Our draw point left, draw point left, draw point right. So these two lines we will want to be connecting. These lines won't have anything to connect to, so I can select some of them, delete them. that's fine for now. If I don't like things, I can always delete them later. So let's continue. Okay. So now these draw point left and draw point right have been extended to the middle. And I also did a join. So this joined that point to that point, and then the line was translated up. Oh, and I've also got my lines for my undercut left and right for the development drive there. Okay, that looks fine. We'll continue. So this last step has created the translated lines above these undercut development drives, and that's for the full undercut. And we've also got raise holes that have been created. So I'm pretty happy with how the design has turned out. It hasn't connected here on this side, but we can deal with that later. So I'll continue for the last step. So the last step, it trimmed it to a perimeter. There might be a couple little changes that I'd like to make, but you know, due to time, I'll just keep on going. So at this point, this is the last step. I can continue, and then my choice is, it will give me the choice to either keep. So do I want to save my design and exit or restore the original design? I'm happy with my design for now, so I'll hit OK. Because I used clipping, there might be some very small strings, so I will use my data validation wizard on my FXS. But I'm going to take these right through to generating the wireframes so we can see what they look like in 3D. Sure. Good. So now I just need to reapply my design definitions. Just make sure. And then I will create my generate my walls and points in my wireframes, and we'll be able to look at this in 3D. I'll ignore that error for now. It's just, I think there was one little line that was clipped by the perimeter that I should have gotten rid of, but missed. So once we have the wireframes, the next steps that you'd have to do with this is to figure out your dependency rules. It's nice with this because everything is very parametric, so even generating your dependencies should be fairly simple because you've already done the work to figure out how you're building things up or how things are related to each other. Alright. So I'll get this on screen and then we can answer some questions. Good. Sorry. First, show intersection. So I've just sliced it through the middle. You can see my undercuts left and right, my undercut development tunnels, and also my left and my even and odd development tunnels with the draw points here. Right. And this is the end result of my quick auto layout run. And yes, you can see also that I've got the raises. All right. Let me flip back to here. Sorry about this. All right. Well, looks like maybe I've answered all your questions, or we'll have to see if anybody emails in with anything. But if you're interested in trying more with auto layout, there is a tutorial for the auto layout tools that has a similar case to what I've shown here today, and that came installed with the program. So you'll be able to just go into the help menu, look up tutorials, and there is an auto layout tutorial for you to run. Thank you.
Thanks for that, Lee. So this does mark the end of today's webinar. Thanks everyone for attending. We do have, is it Aaron Spong? You've got your hand raised there. Did you have a question there, Aaron? If so, you can enter that into your chat box. But for now, we hope that you found the content presented today valuable, everyone. If you did submit a question or if you'd like to submit another one, please rest assured that we have the ability to record these through the system that we're using, and we'll touch base with you afterwards to follow up. You'll now be redirected to an online feedback form. It won't take any more than a few minutes to complete, so if you do have the chance, we'd really appreciate your feedback on how today's webinar went. We'll also be sending out a follow-up email to all of our attendees. This email will provide you with a recording of the webinar as well as the necessary details to contact us should you have any further questions. We look forward to hearing from you soon. Thank you all once again for attending today's webinar, and thank you, Lee.
Thank you.